Okay, welcome everybody. This is section 7.4. Once again, there's a lot of slides in this PowerPoint, but most of them are used to derive the formulas. I'm not too worried about deriving the formulas, but we do need to write the formulas down and just show you I'll show you those slides and talk about getting to the formula. So first, we're going to measure the arc length, the distance from one point to the next around an arc. In algebra, if you remember in algebra, we use this formula that was, hang on, that's, in algebra, we use this formula right here, the distance formula, distance between 2 points. And they're using this formula to derive the formula for measuring the arc around a curve, the length of the arc around a curve. Okay. So just take a look at that formula. And then when we go to the next slide, once again, we're going to be measuring the arc line around the curve. S is the length of the curve. So S, they're using the symbol S as the length around the curve. And then they go through and start deriving. S is the length around the curve. Once again, it's kind of like the distance formula. And I'm not going to go through the whole process, but you can actually kind of look through this whole process here. And you see this is a summation of all these bits and pieces, the change of Y over the change in X. And if you remember, anybody know what the change in Y over the change in X is? What is that formula? What does this represent? Change in Y over change of X? From algebra. Anybody?
Is it the slope?
Yeah, it's the slope. Perfect. This is really important. This is the next slide. So this is the slope. And another way we found the slope in calculus is the derivative of something. So slope is the derivative of the function. So just so they're deriving this formula using the slope, and we're going to be using the derivative of a function. And down here, once again, down at the bottom, we have Y, change in Y over the change in X, which is the slope or the derivative of the function. So that's kind of key if you're going to go through and look at, in the book, they go through the whole thing and try to explain it. So this is our formula. So S is the arc length, and I'm going to actually show you the formula on the next page, but this is our formula that we're going to be using to find the arc length. And I think on the next page, it's a better formula. There we go. So make sure we write this one down right in front of us. And that's with respect to X. You can also do it with respect to Y also. I don't think we do any with respect to Y in the homework or in the PowerPoint. But this is the formula. It's the square root of 1 plus the slope squared, or the derivative squared. All right, so we have to have that written down. There's one other formula I'm going to have you written down. I have it written down right in front of me. I want to keep it right in front of me also. But that's how to find the arc length, the square root of 1 plus the derivative squared. All right, now that we have that, I'll give you a second. And once again, there is a lot of algebra, so be patient with me. I'm going to try to be neat and try to be logical and linear so we can see it all. But it's, most of this, and I think I have some blank spots. Yes, I do. Good. Okay, so we want to find the arc length of this function over this interval. Also, once again, I'm going to write down the formula up here at the top. The arc length equals, we're S, almost looks like an integration symbol. Here's my integration symbol. We're going to integrate from 1/2 to 2 there, over this interval. And it's the square root of 1 plus the derivative squared, dx. So this is a function. So of course, the first thing we want to do is find the derivative of this. So that's going back calculus 1, derivative of x to the 3 over 6. You bring the 3 in front, and then you subtract 1. And I'm going to change this function. I'm already making it too busy here, but I'm going to change this function to 1/2 x to the -1. So I just, the 2 stays on the bottom. I just brought the x up to the top and gave it a -1 power when you bring it up to the top. So the derivative of this, is bring the 1 in, the negative in front, the -1 in front, and then subtract 1. So we end up with a negative 1/2x squared. If I bring the x back down to the bottom. Everybody okay with that? Taking the derivative of this equals this. All right. If we look here, this is 3/6 is 1/2. So I'm going to change this. I'm going to reduce this to 1/2. And I am going to now factor out my y prime. I'm going to factor out, there's a 1/2 in each. So I'm left with x squared minus 1/x squared. So all I did was factor that 3/6 changed to 1/2. They both have a 1/2 in there. So I factored out the 1/2 there. And what we have to do is we have to square. Do you see the function? It says square our derivative. This is our derivative. We have to square it. So that's what I'm going to do next. I'm going to take my derivative and I'm going to square it. So if I square this whole, I'm going to go ahead and write it out. Like I said, that now, I mean, there's just, it's a lot of algebra involved. I'm going to square this whole thing. And when I square this whole thing, 1/2 squared is 1/4. And then x squared minus 1x squared. To square that, you have to write x squared minus 1/x squared times x squared minus 1/x squared. So you write it out twice. We're squaring this and we're squaring this. And so now I'm going to distribute this and I get x4. I get x squared times a -1/x squared is a -1. And then I'm going to multiply these two. -1/x squared times x squared is also a -1. And then when I multiply these two, I get negative times a negative is a positive 1/x4. So I end up with 1/4 x4 minus 2, 1 over x4 plus. Okay, that's what I got so far. Okay, so I'm going to distribute the 1/4 back into here. And I get 1/4 x4. 1/4 times a -2 is a -1/2. -2 over 4, which is a -1/2. And I'm going to put the 1/4 in here. Okay, so this is this. We still have to do 1 plus this now. So I'm going to go to the next, slide, and I'm just going to bring over. I'm going to go to the next slide, and I'm going to bring over what I circled in red to the next slide. So I'm going to give everybody a second if you're still writing, if you are writing or not. But I'm going to take this and bring it to the next slide. So I'll give you a second. There's a lot. I mean, you see that's algebra. First we had some Cal 1 taking the derivative, and now it's just a whole bunch of algebra. Give us a second. Okay, so on the next slide. We're going to start. Well, I should have it red so you know what I brought over in red. I brought over x to the 4th over 4 minus 1/2 plus 1 over x to the 4th. So that's what I brought over. And I'm going to rewrite the formula down. So we have that formula sitting right in front of us. Integration square root 1 plus the derivative squared. And once again, this is the derivative squared. And so what I'm going to do now is put this 1 in front of it. 1 minus, or is it 1 minus? No, it's 1 plus. There's a plus here. Okay, so I haven't put the square root there yet. I want to do all the math inside. It's a whole bunch of algebra inside of there. Okay, so the only thing, so I'm at this. Now I have this entire inside of the square root, 1 plus the derivative squared. If you look, 1 minus 1/2 is a positive 1/2. So now I'm left with x4 over 4 plus 1/2 plus 1 over x4. Do you see? I combine these two. 1 minus 1/2 is a positive 1/2. Now I'm going to do, oh, I think I forgot something. Did I forget something? Let me see where I'm at. No, I think we're okay. Okay, so from here, it's kind of hard to see. It's very difficult, hard to see. But when you do these problems, and you'll see we're going to do one of these problems in the homework, what I'm going to do now is I'm going to factor out. I'm missing something. I'm sorry, but I'm missing something. I'm missing something on the last page. Where did I think I had a 4.
Wouldn't it be on the last one over
There's
X4?
There should be a 4 right here. Yes. Okay.
Yeah, that right there. Yeah.
Thank you. I knew I was missing something because I want to factor out these 4s now. Thanks. Yeah. So I want to factor out the 1/4 out of there. Watch what happens when I do that. So I'm going to factor out a 1/4 from here. When I take this 1/4 out, I'm left with X4. When I factor out 1/4 here, it's like you're dividing or multiplying by 4. If you multiply this by 4 and you're factoring out a 1/4, you end up with a 2 here. When 1/2 divided by 1/4 like that ends up with 2. And then I'm going to take this 1/4 out also, and I end up with this. Okay. So so I factored out a 1/4, and you almost have to see how to factor out a 1/4 from a 1/2. That you end up with 2, or you could say to get rid of it, you multiplied it by 4. If you multiply this by 4 times 1/2 is 2. Multiply this 4, they all cancel. So that's another way of looking at it. And then, do you see now, this is really important that we see what we're about to do here. This is the entire inside, the 1 plus the derivative square. That's the entire inside of that square root. Okay, so I want to make sure we see that. But before I put it back into the square root, this actually factors. It factors to x squared plus 1 over x squared. Except I'm still doing something wrong. I'm missing, I have a minus sign that's wrong. Yeah, let me see, where are we at? No, we're fine. No, we're fine. I'm sorry. There's no minus sign. X squared plus 1 over x squared. This actually factors. Do you see x squared times x squared is x4? When I multiply these two, I get 1. And when I multiply these two, I get 1. And there's my 2 in the middle. And then when I multiply the last 2, I get 1 over x4. So it actually, if you see, this factors to 2 terms that are the same. And we're not going to do this unless the 2 terms are the same. And they are the same. So, and I still have the 1/4 in front. 1/4 x squared plus 1 over x squared squared, because we have it twice. All right, go ahead. Did somebody have a question? That's why I only wanted to do this one section. It's a lot of algebra. If you look at this, it's a lot of algebra. And we want to get a square here because now we're ready. Now we're ready to plug it in. And here's the formula. And let me go back to black. Here's the formula. The square root of, we're putting it in there now, x squared plus 1 over x squared squared. So now we're ready to put it back in there. And if we take the square root of both of these, if you just look, you can, since there's a multiply here, you can do the square root of 1/4 times the square root of x squared plus 1 over x squared. The square root of 1/4 is 1/2. And square root and square cancel. So we're just left with x squared plus 1 over x squared. So this is what we're integrating. So we already, we got rid of the square here. We got rid of the square here because we had a perfect square. And so this is what we're integrating right here. And we're so I'm going to take the 1/2 out in front. And I'm going to bring this x squared to the top by putting in a minus sign. And I can't remember what the original problem said to integrate it to. Let me take a look.
0.5 to 2.
1/2 to 2. Okay, thanks. 1/2 to 2. All right, so we're going to integrate this up over here. And this becomes x3 over 3. And if I add 1 here, it becomes a minus 1 x over 1. So it's just, or -2 plus 1 is a -1. So we'll just leave it like that. Let me erase that line. And I'm gonna go, and we still have, so this, I'm gonna rewrite it, if you guys can see this, x3 over 3. It's not letting me write. Minus 1 over x. Every time I get to the corner, it won't let me. With the 1/2 in it. So this is where we're at right now. And we integrated it and we're going from 1/2 to 3. And I'm going to go ahead, or 1/2 to 2, I'm sorry. And I'm going to bring that on the next page. I'll give you a second. And then we're just going to plug that in and find the answer. All right, let's go to the next page. Oh, or I just can erase that. I didn't have to go to another page. So we are at this point right here. So first we plug 2 into there. We have 1/2. And we're going to plug 2 into it. 2 to the 3rd power is 8. So we get 8 over 3 minus 1/2. Plug the 2 into there. And then we're going to subtract 1/2 in there. Boy, is that right? Yeah, that's definitely right. Okay, let me get my calculator out. If I plug 1/2 or 0.5, raise it to the 3rd power, and then divide it by 3, and I change it back to a fraction. Just calculate it as a fraction. 0.5 raised to the 3rd power divided by 3. Change it back to a fraction. I get 1/24. And then if you put 0.5 into here, you get 2. And then we're going to put all of this in our calculator. Good Lord. 8/3 minus 1/2 minus parentheses 1/24 minus 2 and then times 1/2. And I get 33/16 when it's in fraction form. Don't keep everything in a fraction, so make sure you know how to do fractions on your calculator and all that. But when you do all that math, that's what you get. And yeah, that's what I got the first time. So that is the arc length. There's a lot there. I mean, we're taking derivatives, and then we're doing a lot of algebra to get a square, because we're going to take the square root and we want to get that square. We want that square to disappear with the square root. We want to be able to take it out of there. So that's a lot of work. Yes.
Wouldn't the negative carry over to make that 2 a positive?
Well, I put it all in my calculator. So I put it in my calculator exactly like this, and this is what I got. Yeah. So yes, it would. This would change negative and this would change positive. But if you put it, I mean, I put it with the parentheses and everything. I put it in the calculator exactly like this, and this is what I get.
I did it both ways with the calculator using the integral and then on the paper, and yeah, I got the same thing.
Okay, good. All right. Let's try the next one. Find the arc length. So we're going to do 2 of these, and then we'll do probably 2 of these in the homework, because there's a lot. All right, so we're going to do the same thing. If it says find the arc length, the first thing I'm going to write down so everybody sees it, so I see it, is the formula. 1 plus the derivative squared. That's it, dx. And it says integrate from 0 to pi/4. Here's y, so we have to find y prime. We are going to say u equals the cosine of x. So the derivative of u, the derivative of cosine of x, anybody got it memorized?
Sine of x?
Close.
Negative sine of x.
Yeah, negative sine over x. There we go. There we go. Don't forget, you can use your formula sheets and all that. So make sure you always have those handy. So we are going to this, if y equals the natural log of u, the derivative of y equals 1/u du. So the derivative of y equals du is the negative sine of x, and u is the cosine of x, which also equals negative tangent of x. Sine over cosine is tangent. So the derivative equals negative tangent of x. All right. Give you a second on that. Okay, so
So would we then use the identity here? Tan squared theta plus 1 equals secant squared theta.
Yes, perfect.
Okay.
So we're going to integrate square root 1 plus the derivative with, plus we have a negative tangent, so it's a minus tangent, and we're going to square it because we have to square our derivative. So this is what we are integrating. Now, before we integrate, just like he said, go to your trig formula sheet, and I would do that right now if you guys have that trig formula sheet, just so you can see it. You know, 1 minus tangent x, look for that and see if you can see on there what it changes to. Oh, it's yeah.
Is it not supposed to be 1 plus?
It's supposed to be 1 plus. Oh,
Yeah.
wait, why is it supposed to be 1 plus? Let me take a look at that.
From the
No.
formula?
No.
Oh, we got negative tangent of x. Okay, so never mind. We got negative tangent of x.
Yes.
Okay.
Yes. So if we look on our formula sheet, somewhere it's on here. That doesn't look right.
Well, the one I had found was 1 plus, but we've got
Yes,
1
but-
minus. So
Yeah, so it's something's not right. Something that's not a
well, if you square negative tangent of x, then that gives
Oh,
you
that's-
positive tangent.
there you go. I squared it wrong. I'm sorry. So let me do this down here. Thank you very much. This is our slope. This is our slope, negative tangent x. We have to square it. So it becomes negative times a negative is a positive. So it becomes tangent square x positive. So then I jumped the gun when I said we had a negative, but when we square a negative, negative times a negative is a positive. So it does become a positive. And this is still, we're integrating. We haven't integrated nothing yet. And on our formula sheet, tangent square x plus 1 equals secant square x. So this is from our trig identities.
So then does that just come out to be secant of x? Since we're square rooting a square?
Yes.
Okay.
So now we're in a square root and square cancel, and we're integrating the secant of x. Okay, secant of x. Sex. Okay, I'm going to the next page now. So this is what I'm taking to the next page. So there we go. That makes sense. This is the derivative. If you take the derivative and square it, you end up with a positive. And then 1 plus tangent square x is secant square x, and the square root of secant square is just secant, and we're going to transfer over secant of x to the next page. Integrated. Okay, so we are bringing over integration of the secant of x. Okay, so now we go to our integration formula sheet. Oh, these formula sheets really come in handy. And look, and it's kind of unusual compared to the rest of them that are there. Secant squared x integrates to the natural log of secant x plus tangent x plus c, but we're not doing the c since we're going to plug some numbers in there. So this is the integration. So I mean, from here, when we integrate, we're ended up with natural log secant x plus tangent x, and we're integrating from 0 to pi over 4. All right, so let's plug pi over to 4 in there first. Now, let me put it down here. ln secant pi over 4 plus tangent pi over 4 minus ln secant 0 plus tangent 0 and secant of pi over 4 is, look on your unit circle, the secant is 1 over cosine, and cosine is square root of 2 over 2, and if you flip that, you get, so cosine is the square root of 2 over 2. So secant is 2 over the square root of 2. If you multiply both sides by the square root of 2 by 1, what happens is you end up with 2 square root of 2 over square root of 4, which is 2. These cancel out. So you're just left with secant a square root of 2. So this, you're just left with, I don't know why I keep on writing the secant,
Square root of 2.
just the square root of 2.
Yeah.
So this equals the natural log of the square root of 2. And tangent of pi over 4 is 1. Square root of 2 over 2 divided by the square root of 2 over 2. Minus the natural log. The secant of 0 is 1 over cosine. Well, cosine is 1, so 1 over 1 is still going to give us 1. And this will give us 0. Tangent of 0 is 0. So that's what our answer is. The natural log of square root of 2 plus 1 minus the natural log of 1. Anybody know what the natural log of 1 is?
0?
Yep.
No, wait.
Yeah, the natural log has a base e to the 0 power equals 1. So, you can try it on your calculator, natural log of 1, you get 0, yeah. So this is our answer. The natural log of square root of 2 plus 1. If they want a decimal answer, then you can just put that in your calculator and give them a decimal answer. So if you notice, it's really an easy formula. It's just, there's a lot of work getting to the answer. There's definitely a lot of work there. And I think if you notice on both of these, we had this elaborate thing, and somehow we had to square it, put it all together and square it on the inside. Once we get it squared, then the square root and the square will cancel. So that's the goal when we're doing these. Somehow get whatever's inside the square root into a square form, so it will cancel with the square root. And then we're able to integrate it and get to the answer. All right. Next is, so we did the arc length. Now, what if we did the arc length and we have the arc length and we revolve it? What that gives us is a surface area. So if we revolve it around the x-axis or the y-axis, that one line, that curve, if we revolve it, rotate it around the x-axis, you end up with a picture that gets you and gives you the surface area. So just like this, let's call this the length, and if we revolve it around, we end up with finding the surface area for this formula. And they go through showing you, I mean, in this PowerPoint and in the book, they go through showing you, you know, how what they're talking about, the two different radiuses, and show you the formulas. But this is what we need to write down. This is the formula for the area of a surface that's revolving around an axis. So we're going to find the area of a surface that revolves around the axis. And once again, I think we're doing everything in this class with respect to X. So you actually want to, yeah, I mean, so we have it in case we're going to do one in respect to Y, but I think I checked the homework. I don't see any with respect to Y. And I didn't see any in the book, but they have it there just in case. The key to this formula is this, I think this R right here. So it's 2 pi, then this R, and then the square root of 1 plus the derivative squared. This is the once again, what we just found, the distance of an arc. And then we're going to revolve it and multiply it by this R. So this R tells us somewhere, right here, the Rx in front of the square root is the distance between the graph of F and the X axis of revolution. So the Rx is the distance between the graph, the function that we're talking about, and the axis of revolution. So that's really important because sometimes it's the function and sometimes it's X. And I'm going to we'll do one of each of these problems to see this. So that Rx is the distance between the axis of revolution and the actual graph. So make sure we have that written down. I have it written down on my paper. This is the second formula that we need for this section. All right, let's look at a problem. Here's our problem. And it says the axis of revolution is the x-axis. So if you look at Rx, I mean, this is really important that we know the Rx in the formula. Once again, I'm going to write down the formula right here. 2 pi integrating Rx square root of 1 plus the derivative squared. And this Rx, once again, is the distance from the graph to the axis of revolution. The axis of revolution is the x-axis. So if you look, the distance is the function, this x3. We put a 1 in here and it tells us the distance there, y equals whatever. We put a 0 in there or whatever number this is, and it tells us the distance. So in this case, Rx is x to the third power. It's our function. Rx is our function. And then so we just have to find the derivative. And I'm going to go to the next page. Wanted to show that picture. All right, so there we go. So Rx, so let's plug everything in then. 2 pi integrating Rx is x to the third. Oh, if our function is x to the third, then our derivative is 3x squared. 1 plus f prime, which is 3x squared, And then we're going to square it. So when I do this, I end up with 2 pi. Once again, I think if we go back, it says we're integrating from 0 to 1. Let's just go back really quick. We are integrating from 0 to 1. Right there, 0 to 1. X3 square root 1 plus the derivative of x3 is 3x squared. And inside here, I end up with 9x squared, squaring the 3 and squaring the x. All right, now we need to integrate this. If we look at this, oh wait, did anybody see what I did wrong?
Yeah, it's supposed to be 3x squared, right?
Yes, thank you.
So it should be 9x, yeah.
9x4. Because we're squaring the 3 and we're squaring the x squared. 3x squared is 9x4. All right, so to integrate this, it's really not a hard integration. If we say u equals 1 plus 9x4, so the derivative of u, derivative of 1 is 0, the derivative of 9x4 is 36x3. All right, so if you notice, this is du, and this should be du. So this is over here, this is just u, and this is du. So we're missing a 36. If I have a 36, if I put a 36 there for the du, then I have to put a 36 down out here. So they canceled each other out. So now I'm integrating from 0 to 1. 2 over 36 is 1 over 18 pi. And this becomes the square root of u du. And once again, if I integrate, I'm going to change it to u is 1/2. U square root of u is u to 1/2. So when we integrate that, we add 1. Add 1 here, and I end up with u to the 3 over 2. And then I put 3 over 2. You put 3 over 2 on the bottom, or you can flip that 2 to the top. So this is the integration from 0 to 1. Don't forget we have 1 over 18 pi out in front. Now I'm going to plug my u back in, my x's back into the u. 1 over 18. And I get, oh, this is what I'm going to do also. I'm going to pull this 2/3 out and bring it over here. I'm going to change my color and pull the 2/3 out over here. And if you notice that becomes 2 cancels with this and 9, and I get pi over 20. I'll end up with pi over 27. And that becomes a 9. 9 times 3 is 27. So I end up with u to the 3 over 2. 1 over 0, or 1 to 0. And I'm going to rewrite it one more time with plugging it in like I said I was going to do, and I didn't. Pi over 27 U is 1 plus 9x4 to the 3 over 2, integrating from 0. We're plugging in 0 to 1. So this is what we do. We plug 1 into it. If I plug 1 into this formula, I get 1 to the 4th is 1. I get not, so that's 9. 1 plus 9 is 10. So I get pi over 27. And when I plug 1 in, I get 10 to the 3 over 2. If I plug 0 in here, I just get, if I plug 0 in there, that whole turns 0. I just have a 1 right there. And 1 to the 3 over 2 is still 1. So this is my answer. That's as far as I'm going to take it. If they want a decimal, you can plug it in your calculator and get a decimal. But that's as far as I'm going to take it. You see, there's a lot. I mean, that's all algebra. If you look at that, I mean, there's a lot of algebra involved. I mean, we have a little Cal 1, taking derivatives. There's Cal 2, finding the derivative when you make u and then du. So that one wasn't too bad, but you see, it's kind of elaborate to go through the whole process. It really, I mean, you're really going to have to do this and very carefully go through that whole process. Oh, can I ask how it worked out? Was everybody able to do most of the homework with those homework sheets I posted? Was that helpful?
Yes, that
Yeah.
actually did help, having some type
Yeah,
of
I think-
guide to go through it. Yeah.
Good. I wasn't sure if that, oh, is this the, oh, this is this what we just did. Okay. All right, so this is the, is this the same problem? Yes. Yeah, oh, it's the same problem. Oh, that's what we got, yeah. Oh, they did take it a little further in the slide. They gave us a decimal equivalent. All right. I mean, they'll ask for it. Don't ever put a decimal equivalent unless they say round it to a certain decimal place or something like that. All right, so now we're gonna do this. So this is a little different. And I'm gonna put the formula up first because you have to pay attention to this. This is the last one on the slide here. If we look at the function, I'm going to draw I mean, they gave us pictures for all of them except this one. From 0 to square root of 2, let's say this is the part right here. This is the graph. It's a parabola, right? It's a parabola. But we're going to go from 0 to square root of 2 only. So we don't need the negative side of the parabola, the function. And we're going to do it, we're revolving it on the y-axis, it says. So this is the difference between the formulas and the y-axis. The formula is exactly the same. Let me write down the formula, integrating 2 pi in front of it, rx, square root of 1 plus the derivative squared. Okay, so there's the formula. Now this Rx is what I want to focus on. This is the important part. Since we're rotating it on the y-axis, Rx is the distance from the graph to the axis of revolution. So the distance from the graph to the axis of revolution are these blue lines, if you look at it. And that is not the function. Do you see when it's not our function, this is our function. It's not the function because it's sideways there. So we don't put the function in here. We don't put x squared in here like we did in the last one. The last one, it was on the x-axis, and if you look going up, down, each one of these gave us the y part of the function. But sideways, the way we're doing it now doesn't give us the y part of the function. It gives us the x part of the function. So in this formula, we're putting 2 pi, and instead of the function, we're just putting x. It's the x part of the function, 1 plus the derivative. So anytime you go to the y function, and if you look here, it's talking about each of the x points at that spot. So we put x here instead of the actual function, just the x. And then here's our function on the side. Function is x squared. The derivative of our function is 2x. So that's the key, that the little blurb in that in the formula says Rx is the distance from the axis of revolution to our graph. And in this case, it's going to be an x value, not the function, not the y value of the function, but the x value of the function. And so then the derivative is 2x, and we square that.
So we're not having to do any changes such as it becoming square root of y equals x. We're not having to do anything like that like we did in the other ones.
No. See, yeah, that brings up a really good point. That no, it's not. We're doing everything with respect to x because the problem is with respect to x. If the problem was with respect to y, then we're doing it with respect to y. But no, it's not like the previous problems that we did in other sections. No, you're not changing it because of the axis of revolution. You change it with respect to y. In this problem, we don't do that. Thanks for bringing that up. Everything stays in with respect to x. The only thing that changes is this Rx. This Rx is no longer the function. It becomes just x. It's not the function. It just becomes the x part, not the y part of the function. You know, this is so hard in algebra to teach everybody that f of x is really y. So we're putting the y, when you write down the function, that's the y part. But in this case, it's the x part because we're going to x-axis. I mean, we're rotating on the y-axis, but the line tells us what the x distance is. The distance from the graph to the axis of revolution is the x distance. Right, we're not changing it with respect to y, just like we did on the previous problems. This section, you don't do that. The formulas don't dictate that. All right, so from here, that's a pi. I don't know why I put an x there. We have 2 pi integrating x square root of 1 plus 4x squared. All right, so we're going to do the same thing as we did last time. U equals 1 plus 4x squared. The derivative of u is just 8x. So we are missing, and this is the derivative of u. We're missing an 8. So we put an 8 down here. So this is du, and this is u. And this changes to 1/4 pi over 4, integrating square root of u du. And once again, pi over 4, integrating u to the 1/2 du. And I think I'm going to take this to the next page. I'll give you a second. try to go. So we are at I over 4, integrating u to the 1/2. Okay, integrating u to the 1/2, add 1 and you get u to the 3 over 2 over 3 over 2 over 4 and pi over 4. Oh, I'm going to bring the 2/3 out of here again. So I'm going to bring the 2/3 over here and I end up, the 2 cancels with the 4 and I end up with pi over 6. U to the 3 over 2, u is, here's my u, is 1 plus 4x, 1 plus 4x squared to the 3 over 2. Yes, and that integrates from 0 to the square root of 2. And then we just have to plug this stuff in. Okay, let's see. First we plug square root of 2 in here. Well, let's do pi over 6. And if I plug square root of 2 in here, let me show you. I'm gonna put it up down here. 1 plus 4 and square root of 2 squared. Square root of 2 squared becomes 2. So this is 1 plus 4 times 2 is 8. So we end up with 9. When I plug square root of 2 in here, I end up with 9. 9 to the 3 over 2. When I plug 0 in there, I just end up with 1 to the 3 over 2. Oh, 9 to the 3 over 2. The square root of 9 is 3. 3 to the 3rd power is 27. So this becomes 27 minus 1, which ends up becoming pi over 6 times 26, which becomes 26 over 6 pi, which they both reduce to 13. Divided by 2 is 13 over 3 pi. There's our answer. You see, there's a lot of, I mean, that's just basic math and algebra. I mean, there's a lot there. I tell all my Calculus 1 students that if you didn't get an A in algebra, you're gonna have a problem. Because there's a lot of algebra in the calculus, especially Calculus 1. There was a lot of algebra. And you see in this section, there's a ton of algebra. You're just manipulating the problem to get to an answer that you can recognize. All right, so that is the PowerPoint. We have time. I want to go to the homework. What time do we normally get out here? 12:35. Okay, yeah. I want to do a couple in the homework. It's going to be similar to what we're doing here, but I just want you to see it again. Let me get to the homework. 7.4. Number 1. And they want us to find the arc length. So as soon as I see arc length, the first thing I want to do always is write down the formula, just so I see it in front of me. 1 plus the derivative of the function squared. So I like to see that right in front of me when I'm doing this. So that's a little crazy here. If you look, they show us yeah, they show us a function here. I guess we can, I just want to, I guess we can follow along right here.
Are we gonna be getting a new formula sheet for these new ones? Or should we just add this to our own one that we make?
No, add this to the ones you make, yes.
Okay.
The ones from each section, yeah, I mean, there's only the two formulas in this section.
Right.
I would start writing down every formula as we're moving along in this section. Let's take we'll go through the whole. Did we want to go through the whole process? Yeah, let's go through. I mean, it's the calculus and the derivative, but let's deal with. Let me go back up to the top and show the function. Not letting me. There we go. So here's our function. Y equals 2/3 x squared plus 1, 3/2. If I say u equals x squared plus 1, then the derivative of u is 2x. So y equals 2/3 u to 3/2. So taking the derivative, we're going to bring this 3/2 down. 3/2 times 2/3 u, and then subtract 1. 3/2 minus 2/2 is 1/2. This all cancels. And then we end up with the du. So y prime equals u to the 1/2 du equals u to the 1/2 is a square root. Well, I guess u is x squared plus 1 to the 1/2. Du is 2x. So that's our y prime. And I want to show that down below. Right here. And if you notice, we're integrating from 0 to 1. Okay, so that's our y prime, and we have to square this mess. I mean, this becomes a huge algebra problem. It really does, a big algebra. If you look, here is our y prime, and we're going to do 1 plus y prime squared. And that doesn't.
Don't we just?
Yeah,
2x times
that's
2x
good.
or
Yeah.
squared, and then the square root cancels out because we're squaring that.
Yeah, so let me try to do this here on this side. So so we're now putting it in the square. 1 plus the derivative, which is x squared plus 1 to the 1/2. And then we square this whole thing. Oh, wait, there's a 2x also. Erase. And it doesn't matter where we put the 2x. I'm going to put it right here. And we square it. So if we square this, we end up with just x squared plus 1. Square and the square root cancel out. If we square this, we end up with 4x squared. So from here, we're going to distribute 1 plus x, 4x to the fourth plus 4x squared. And just like we did in the first problem, let me put it in the correct order. 4x4 plus 4x squared plus 1. Just like we did in the PowerPoints, the first two problems, we're looking to try to make a perfect square out of this. And this does factor to 2x squared plus 1 times 2x squared plus 1. You see this factors out. So we end up with 2x squared plus 1 squared on the inside. Right here. Okay, so I'm going to erase the stuff on the right-hand side. All this stuff over here, I'm going to erase. If you want to write, if anybody's writing anything down, write that down. I'm going to erase that here in a second. It's so much easier when I have a big board for the classroom. So much easier. I should tell them I'm only going to teach this class face-to-face for now on. It's just a lot easier that way. But not many people wanted to come face-to-face. I actually had a Calculus 2 class scheduled face-to-face and nobody signed up for it. Well, a couple of people, I think they kicked them out.
No, we don't want the Rona.
I'm teaching one online and one remote. So, all right. Let me erase this part here. I mean, we're at the end. We integrated and we ended up with 2x squared plus 1. The whole thing was in the, squared. The whole thing was in the square root, so they cancel out. And we ended up with the 2x squared plus 1 from 0 to 1. And then, we haven't integrated yet. Sorry.
I made a mistake. I wanted the homework. I forgot to do the integration. It was like completely wrong answer. I was like, oh my God, I got to go back and start over again.
So then we add the 3 and bring in the 3 to the bottom. Integrating of a constant is just x and the constant. Oh, get rid of this. So this is what we have from 0 to 1. And they have the answer over there. I'm going to leave it to you to plug. Oh, you plug 1 in there. And you get 2/3 plus 1, and then plug 0 in there, minus 0. 2/3 plus 1 is 5/3. 1 is 1 is 3 over 3. So 2 over 3 plus 3 over 3 is 5/3. So you see, I mean, for those, you have to try to find something to square it. We still have time, good, because I wanted to do, hopefully I have time to do 3 more, the 3 more that I wanted to do. Let me see what's the next. Did I want to do this one next? I don't think it was this. Oh, I don't think it was that one. No. I think I wanted to go straight to number 7. So I guess I'm only going to do 1 more. I want to do number 7. This one here. And use the integration capabilities, a graphing utility to approximate the surface area. So they say approximate the surface area around to 3 decimals. So they definitely want a decimal answer at the end. And if I remember right, I don't think I got that answer. So when I tried it, I might have had a different problem, but I don't think I got that particular answer. So let's first write down the formula over here. Put this up higher. I'm gonna put the formula right here. 2 pi integrate Rx square root of 1 plus the derivative squared. And if we look, it says axis of revolution is the y-axis. So this is, since it's the y-axis, this is going to be x, not the function. And you can verify that by looking at the actual graph. I think the graph, I can't remember what the graph looked like. I could put it on my calculator. But you can see, I think it looks like this. There, from the y-axis to this gives you the x values. You see the x values. And that's why we put the x there. If it was the x-axis, then the distance from the graph to the x-axis would be the function, whatever the function is. In this case, the function is a natural log of x. Okay. So we're first going to take the derivative. Here's y, natural log of x. Let's take the derivative of that. 1 over x. And then we're going to square it. Right, we're going to plug it in there. Maybe I shouldn't have made a big mess right there. Square root. There's an x out here. 1 plus 1 over x squared. And this becomes x square root of 1 plus 1 over x squared. And then we want to combine all this. This becomes, you can say x squared over x squared plus 1 over x squared. 1 is anything over itself. So then this becomes x squared plus 1 over x squared. And that's how they got to here. This part right here. From the inside. So we're integrating it, and it's from 1 to e to the 4 x squared plus 1 over x squared. And if you look, you can break this apart. You can break this apart. Once again, it's just going back to your algebra skills. This is the same thing as saying the square root of x squared plus 1 over the square root of x squared, which means this just becomes x on the bottom. Square root and square cancel. So that x is on the bottom and it comes out. So this whole thing was the square root of x. This comes out as an x on the bottom. And these end up canceling. So we end up with integrating from 1 to e to the 4th square root of x squared plus 1. All right. And don't forget, I forgot the 2 pi sitting out in front also in the original formula. At this point,
If it's telling us to use a graphing utility like this.
yes, yes.
Are we just supposed to be putting it all in our calculator?
You
Like, are we gonna
can,
have anything like this on the test where it just tells us to use a calculator like this?
well, it's gonna say it, but if it's a show your work, I want to see the work.
Okay,
Okay, that's why, I mean, now we're just integrating this. We're gonna just integrate this. And I want to stop here. I even put a little a note here to stop here. I'm not sure why. Oh, I think this is where I would use the calculator at this point. I wanted to see if we could integrate this. So let's call this a homework assignment. I think that's what I wanted to do. 2du, wait, u is that du is 2x. Yeah, I think I'm gonna stop here because let's do this. Can we integrate this? Can we integrate this? And I want, if you guys do, this is going to be like a bonus problem. I want to see the integration of this. I'm going to put a Dropbox in the week 5 module. And I want this integrated to see if you can get to this answer. So show me the integration. Show me this integration. That's what I wanted. Show me that integration if we can get to it, if we can do that. So that's going to be a bonus problem. Turn that in by Thursday at the beginning of class in the Dropbox that I'm going to put in week 5 module. Okay, so this is, I'm going to put this in the Dropbox. And the main thing I wanted to show out of this, that y-axis again, this y-axis changes this Rx. If it was the x-axis, it would be the function, whatever the function was, and the function in this problem was what, natural log of x. But here it's just x, and because of the y-axis. So this is a bonus problem, and I'm going to write, I have it written down right here. I said, make it as a bonus. Make as bonus. I want to see the integration on that, if you can integrate that. So what I circled is the bonus problem, and that needs to be turned in by Thursday if you want to try for the bonus points. I think that's all I had for the day. We're near the end. Yes, I think that's all I had. If you look, there's 7 problems in here in the homework. And then one of those is just setting the problem up like that. Oh, actually, you had to put the answer down also. All right, I think that's all I had for the day. Once again, that was a bonus problem that I mentioned. And I'll see everybody on Thursday. Bye, everybody. I'll hang around. Any questions?
Hi, Professor.
Hi, bye. Hi, bye. Got a few more minutes. Any questions?
Just kind of a general one. Back in 7.2 homework, let me see if I can bring up my homework. Where are you at? Oh, it's this one. Sorry, I got like 5 folders for all these classes. It's more just when we're doing about the specific problem I have. Where are you at?
Seven
7.2s. It was mainly just figuring out. Okay, here we go. Oh wait, which one was this? That's 7.1. Okay, here we go. Number 5. So to get the big R of X, for my value, my Y was equal to 7. So to get the value of big R of X is 7 minus X.
Do you see my screen?
Yes.
I have that exact problem up here. Okay.
Yeah. So for me, it's more just, I mean, I can kind of simply just 7 minus X, and that's kind of the way it was for even the next problem there. But what is the way of how we determine that it's going to be 7 minus X for the big RX? Like, the only thing I can come up with is we're kind of getting what we did back in 7.1, where it is the whole line of 7 minus the line of X, and then that turns into 7 minus X. That, like, or is that?
Oh, because we're revolving it around, we're not revolving around an axis, we're revolving it around a line of Y equals X.
Right.
Okay.
So I'm trying to just figure out, like, what is the method of determining what that is for R of X, the big R of X. And the only way because when they do to watch it, he just says, oh, well, big R of X is 5 minus X, which because there was a value of 5. The only thing I can come up with is from our earlier, what was it, 7.1, where you get the line above, which would just be a straight value of 7, minus the line underneath, which is X, so 7 minus X. That's the only way I'd come up with where we get 7 minus X. But I don't know if that's the correct, because if we get more complicated later, I want to know how did we get the big R of X on there?
Right. Well, since we're revolving it around this line, yeah, it just starts at 7. I don't know any other way of explaining that. And the small r is the 2, the whole.
Yeah.
Well, it's the, I guess it's the highest point to the, I mean, the longest point from, I mean, this is the longest point, which is 7. I would just explain it that way. I don't know.
So is it just basically like we were doing, I guess in 7.1, if I was getting the shadow, because I think of it as shadows, the shadow of the
Yes.
entire 7 line minus what would be taken out by the X line?
Yes, yes.
So is that what we're doing? Okay.
Yes, same thing, yes.
Okay.
Yes.
I guess, yeah, that was just, I just wanted to figure out if that was the way to do it. Okay.
Yeah, yeah.
That's it. I think that's it for my homeworks.
Yeah.
Oh, so for next week, how are we doing as far as a test? What you said you were going to be changing something?
Yeah, I don't think we're going to take the test on Thursday. I think I'm going to give you Friday, Saturday, Sunday, Monday to take both parts of the test. because there's 4 sections this week. You saw that one section that we just did. For me, I think it's too much to go over 2 sections in one day. So I'm going to cover a section today. I think I might do 1 section on a video for you guys and then another section, but I'll do at least 1 more section next week. And then Thursday, maybe next week, I have some kind of a review or a quiz for a review or something like that. And then let you guys take the test at any time you want. Thursday, Friday, Saturday, Sunday, or Monday, starting on Thursday. I'll give you 4 or 5 days to take the test, the 2 parts of the test. Rather than doing it like we did last time, we just took the one test on Thursday. We took the part A on Thursday, and then you guys did it. It seemed like everybody bombed the part. Maybe I made the part A too soon because a lot of people bomb part A, the multiple
choice part.
Yeah. I think it was too. Or not enough people had their homework done. So I'm going to give you a little bit more time. So I'm going to do. I did 7.4 today. Either 7.5 I might do on a video and then do 7.6 for you next time. But then I'll do 1 section on Tuesday of next week. And then we'll do something on Thursday, maybe some homework or some kind of a review or something on Thursday of next week.
Okay. And you asked during the lecture today if having those examples printed out or whatever helped us. I found it very helpful because there's some times where I get stuck on a question. I have no idea like where even to start, and seeing where they start the question, start going into it really helps me, get on the path for it.
Right.
So that really did help me out.
And honestly, especially when they do the algebra stuff, they don't tell you how they do it.
Right.
They just said, we went from here to here. And so it's good to see that when you're doing the algebra part, what it should look like when you're done doing the algebra part. So maybe I'll do that more often. I hate people relying on it too much, but I do want people to be able to not spend hours. If you're spending like 2 hours on a problem, I think that's too much.
I think, and especially my mindset is if I don't do a problem, odds are with my bad luck, that problem's going to be on a test. And if I don't learn how to do it, I'm screwed for the test. So that for me, I'll spend the 2 hours to try and figure it out, which is a problem.
Right.
Yeah. Because I've had it happen in Cal 1. It was the bacteria problem we had on this test was a problem I had in Cal 1. I didn't do it in the homework because I was like, that's too long. That looks like a lot of work. I didn't do it. It ended up being on the test. I didn't get the question. And luckily, I finally learned how to do it. And so we had it on this test. I was able to do it. So
good.
Yeah. All right. Well, I'll get to the work. I'll get to the work. And thank you for explanation for this one. Yeah.
Sure thing.
Okay. Have a good day. Bye.
Bye. Kyle, did you have a question? Are you there?